Hello children, in this chapter we will be talking about gravitation, universal law of gravitation, gravity, mass and weight and free fall. All these concepts we will be discussing in this chapter, and let's move on to the first slide. What all things are we studying or we discuss in this video? Yes, these are the main points that we discuss in this video. Universal law of gravitation, its derivation. Derivation means gravitational constant, also importance of universal law of gravitation. So here I have given you two different pictures in which some questions are asked by the two different girls. One girl is asking, is the earth spherical in shape? A man on the opposite side of my hemisphere, won't he be standing upside down then? She was asking that, she was thinking about that. Those who are at the opposite hemisphere, they will be upside down. And the raindrops, in which direction the raindrops will be falling though? Yes, it's a genuine question, isn't it? You might have also thought like this. And a girl is enjoying the beauty of the rain. At the same time, she was having some questions like, all the raindrops from the sky, if they went upwards, would we get water? No, we are coming downwards. That's why we are getting water. So we are going to discuss all these things, all these questions and all these concepts with the help of Sir Isaac Newton. Yes, Isaac Newton, sir, is sitting under a tree. At that time, you know this famous story, isn't it? Falling of apple on his head. Actually, he was undergoing, at that time, the world was undergoing a plague pandemic. Just like corona pandemic, plague was there. And he came back from his college to home, and he was doing his famous research works and all. At that time he started thinking about this, why these fruits are coming down, why these planets are moving around the sun, why the moon or any natural satellites which are revolving around these planets. All these questions were there in his mind, and he was trying to find the answer of all these questions with the help of Kepler's law. Okay, and he find out that every object in the universe attracts every other object with a force which is proportional to the product of their masses and inversely proportional to the square of the distance between them. Yes, this is known as universal law of gravitation. This, according to this universal law of gravitation, each and every object in this universe attract with each other with a force which is proportional to the product of their masses. That is, if capital M is the mass of one object and small m is the mass of another object, it is directly proportional to the product. Product means what? Result of multiplication, isn't it? Product of the masses of the objects and inversely proportional to the square of the distance between them. If d is the distance between the two objects, it is inversely proportional to the square of the distance between them. So we can do the derivation here. Here two objects are given. This object is having a mass of m1 and the small object is having a mass of m2, and they are separated by a distance of small d. So if two bodies are separated by small d, this F force is directly proportional to m and m2, and force is inversely proportional to 1 by d square. Okay, so combining force is directly proportional to 1 by d square, that is, force is inversely proportional to d square. Combining these two, equation 1 and 2, we get F is directly proportional to m1 m2 divided by d square. So in order to remove this proportionality constant, we have to remove this proportionality sign. So we can include one proportionality constant that is known as universal gravitational constant, this G, gravitational constant. So here we have used G as the gravitational constant, and its value is 6.67 into 10 raised to minus 11 Newton meter square per kilogram square. It was Henry Cavendish, a scientist, who determined the value of G for the first time through experiment. So you will have to remember the name of the scientist also. The scientist who found out the value of G, that is Henry Cavendish. So this derivation is very, very simple and at the same time very, very important also. Okay. In the next slide, I'm giving you some questions. You will have to think about the questions. You will have to work on it and find out the answer and write in the comment section. Okay. Two bodies are at a specific distance so as to attract each other. How many times will the mutual force of attraction be if the mass of one of them is doubled? If mass of one of them is doubled, so any 1m you can take as 2m. Other m, let it be like that only. And you can do this calculation and find out what will be the force of attraction or how many times it will increase or decrease, whatever it is. And second question, what if the mass of both our bodies are double? In the first question, we increased only one of the object's mass. In the second question, we are going to increase or we are going to double, make it twice the mass of both the bodies. And what if the distance between the bodies is double? If we are taking d as 2d, what will happen? What happens when the distance between the bodies is halved? If d is equal to half d, what will be the result? What if the distance is made 1/4? If d is equal to 1 by 4d, then what will be the result? So you can find out the answers and tell me. Okay, next move on to some other question. We told that, or we discussed that there are, according to this universal law of gravitation, each and every object in this universe is attracting, so we all are having an attraction between us. Then why we are not moving towards each other? Just like an apple is falling towards the earth. So according to this third law of motion, for every action there should be an equal and opposite reaction. So the earth also should go towards the apple. Or if you can see in this picture, there is a mutual force of attraction between us, then why don't we come closer by ourselves even when the table is removed? So here the boy was asking like this, why we are not coming closer to each other? So the answer is that their masses, we are having very negligible mass. We are not having mass like an earth, or we are not having mass like the sun or any other planets. Our masses are very, very negligibly small. That's why we don't feel it, isn't it? Of course, earth is attracting the apple and apple is also attracting the earth. But when we compare their masses, this mass of earth is very, very greater than, isn't it? Mass of apple is negligibly small once we compare with the mass of the earth. So if that kind of force is there anywhere on the earth, we also should have moved towards that force. But that is not there. That is why we all are staying at our own position, because we all are having negligible, small, very less mass. Okay, here one question is there. A child of mass 40 kg is sitting at a distance of 1 meter from another child of mass 50 kg. Calculate the gravitational force of attraction between them. So according to this question, one boy is having a weight of 40 kg, mass is equal to 40 kg, and the other boy is having a mass is equal to 50 kg and distance between them is 1 meter. And value of G is equal to 6.67 into 10 raised to minus 11 Newton meter square kilogram raised to minus 2. So here we can find out the value of F. The force between them is F is equal to Gm by d square, that is 6.67 into 10 raised to minus 11 into 40 into 50 divided by 1 square. So when we do this calculation, we are getting the value as 1.334 into 10 raised to minus 7 Newton. So you can see the value, isn't it? This much of smaller value we are getting. 0.000000133 Newton. So that much of less force of attraction will be there between two objects, or between two individuals who are at 1 meter distance and having this much of what we call the mass. Okay, so that thing is clear. So mass is having a considerable importance in gravitational force, because that is directly related to the product of the masses and inversely proportional to the square of the distance between them. Okay, in the next slide, we are going to learn the importance of the universal law of gravitation. The universal law of gravitation successfully explains several phenomena which were believed to be unconnected. Informally, we thought that there are no connection between all these kinds of phenomena that is taking place in the nature. The force that binds us to the earth, the motion of the moon around the earth, the motion of planets around the sun, and the tides due to the moon and the sun. So all these are interconnected, isn't it? The tides and the motion of moon and sun, they are interrelated. The motion of planets and the sun, they are interrelated. The motion of moon and the earth, that is also interconnected. The force that binds us to the earth, why we are binding to the earth, why we are not flying away. So all these are interconnected, and the universal law of gravitation could successfully explain all these concepts. Okay, so thank you so much for watching this video. Please comment your valuable opinion in the comment section, and we will be meeting in the next video with the remaining part of this chapter. Thank you so much for watching the video.